Okay, we're going to do 1953. So the first thing I'm going to do is I'm going to draw my picture. And I have a 6 kilogram block, and I have a 4 kilogram block, and I have a force of 30 newtons that's pulling on them. Now, I have a tension here in this rope in between those two blocks. So the question says determine the acceleration of the system and determine the tension of the string. Now, normally on a multiple choice question, they're not going to tell you find the acceleration of the system, but that's what you need to do first, okay? And then that's how you would find the tension. So we're going to take this as a system. So we're going to apply Newton's second law to the system and say summation of F net is equal to MA. But this net force is going to be the sum of the two masses. So that's going to be M1 plus M2 times A. So A is equal to F net. And the net force is the only force acting on it is the 30 Newton force to the right, which I didn't write, over M1 plus M2. So this is equal to 30 newtons divided by 6 kilograms plus 4 kilograms. So 30 over 10 is equal to 3 meters per second squared. And remember, a Newton is a kilogram meter per second squared. So this cancels with that, and I end up with my correct unit. And again, I didn't write underneath here. If we look at our free, the only force, the net force is 30. Okay, so that's part A. For part B, it says, what is the tension? Now, there's actually two ways to do it, so I'm going to show you both, because you can always check your work for a problem that's simple like this. The way that you do this is you draw a free body diagram on the block. Now, normally I would do the block that only, let's say, has one force. So the 6 kilogram block has the tension going this way. So what I can do is I can apply Newton's second law to this block and say summation of F of x is equal to MA. So what are the forces that are acting on this one block? Well, I have the tension, which is going to the right, which I'm calling positive, and that's equal to MA. So the tension is 6 kilograms times 3 meters per second squared, so the tension is equal to 18 newtons. Now remember, because this system is moving together, they're moving with the same acceleration, each block. Now, if I want to check my work, I could look at the other block. So let's go ahead and do that, or maybe that's the way I thought to do it. I have my 4 kilogram block, and I have this force here, which I know is 30 newtons, and then the tension, one string is one tension, is going this way. So now if I do the other block, I could say summation of F of x is equal to MA. So what are all the forces going in the x direction? Well, this is going to the right, so that's positive. That's going to the left, so that's negative, is equal to MA. And if I want to solve for the tension, I'll move this to this side and that to the other side. So F minus MA is equal to T. So 30 newtons minus 4 kilograms times 3 meters per second squared is equal to T. So 30 minus 12 is equal to 18 newtons. So I get the same answer. So obviously it's easier to do it here when you have one force. That doesn't mean this is incorrect. It's just another way to do it. You can either apply Newton's second law to this block or to this block. So both ways are correct. And if you have time, it's always good to check your answer.